Hi everyone, in this video we are going to talk about position vector. So we have x-axis here and the y-axis. This is origin, which is whose coordinates are 0, 0. Okay. So what is a position vector? A position vector is the position of a point with respect to a reference point, in this case origin. So for example, let's say we have a point A whose coordinates in 2 dimensions are x1 and y1. So if a person is at origin, standing at origin, and this person wants to go to the point A, how he can go from O to A? So this is the vector from O to A, which means that this person has to be going x1 units in the x-axis and y1 units in the y-axis. So the vector OA can be written as x1, y1. And this is called the position vector of A, which tells the position of the point with respect to origin. Now let's take another point B. Say B is the point here and B has coordinates x2, y2. So to go from O to B, we have to travel x2 units in the x-axis and y2 units in the y-axis. So the vector OB is x2, y2. So OA and OB are called as the position vector. Now let's take a vector A to B. Why AB is not known as a position vector? AB is actually the displacement vector. AB is the displacement vector. You're initially at the position A, this is the initial point, and this is your final position is at B. So how much distance has been covered to go from A to B? Final position minus initial position in X and final minus initial in Y. So AB is known as a displacement vector. It's not known as a position vector because position vector is always with respect to origin. OA can also be said as a displacement vector, but this displacement always starts from the origin. Okay. In the vector AB, the starting point can be any point in the 2-dimension or 3-dimension, and B can also be any point in 2 or 3-dimension. But the moment we talk about position vector, then that position vector is always with respect to a reference point, and in this case, our reference point is origin. Okay. So now let's take a look at one more thing. As we know that vectors in column vector, if we have x2 minus x1, it means it's x2 y2 minus x1 y1. That's how we do subtraction in column vector form, right? x2 y2 minus x1 y1 is x2 minus x1 and y2 minus y1. But what is x2 y2? x2 y2 is the position vector OB and x1 y1 is the position vector OA. So the vector AB can be written in terms of its position vectors as OB minus OA. Final position minus initial position. And that is true for any vector. Say if you take a vector PQ, then the vector PQ can be written as OQ minus OP. If you have a vector YZ, the vector starts from Y and ends at Z, it can be written as OZ, the final position minus the initial position. Now from this 2-dimensional space, let's take it to 3-dimension. So the point which was on the ground, now let's say that this point is now somewhere in air, like a soap bubble, somewhere floating in air. So we have a point, say X, say point A, which is not on the floor, not in 2-dimension, but is somewhere floating in space. Then, with respect to origin, the coordinates of this point is x, comma y, comma z. The x is the x-axis, this is the y-axis, and this is the z-axis, which means if I want to reach the point A, I must go x units along the x-axis. I must go y units along the y-axis, and I must go z units in height. Then what is the position vector OA? The position vector OA is x, y, z, written in column vector form. And it can also be written as xi, where I is a unit vector in the x direction, plus yj, where j is a unit vector in j direction, in the y direction, and zk, where k is a unit vector in the z-axis. So now what is the unit vector I, j, and k, written in terms of its component? Since I is a unit vector, it's a vector of length 1 unit only in the x-axis. So it's written in column vector form. I is 1, 0, 0. It's just 1 unit in the x-axis, and it doesn't go at all in the y and z-axis. The j is 0, 1, 0, unit vector in the j direction, and k is 0, 0, 1, written in 3 dimension. This is the unit vector along the z-axis. Now, just like how we find the magnitude of a vector in 2 dimension, we can find the magnitude of a vector in 3 dimension also, as using the same formula. So if I have a vector, say AB, and the vector AB has x, y, and z components as A, B, C, then the modulus of the vector AB is square root of A squared plus B squared plus C squared.